Dream Chaser tenacity, standing tall at a NASA facility, nears completion of vibration testing alongside the Shooting Star module. Teaming up with the Vulcan launch vehicle, NASA and Sierra Space aim to redefine space exploration by showcasing a modern spaceplane's capabilities on a mission to the International Space Station. As final tests unfold, anticipation builds for a historic launch that promises to revolutionize our journey beyond the stars. Stay tuned till the end of the video for updates on this cosmic spectacle. But before starting the video, if you are new to our channel, do subscribe and also press the bell icon so you will never miss any updates in the future. Let's dive into the video. The Dream Chaser spaceplane is set to launch in Q1 2024, following final preparations at the Neil Armstrong testing facility in Ohio. The vehicle, developed in 2010, will undergo environmental testing in the thermal vacuum chamber and mechanical vibration facility. Sierra Spacemark announced the vehicle's arrival on November 30th, marking the beginning of the last group of trials for the vehicle. The unfastened vehicle must be fitted into a launch fairing after inspections if both spacecraft made it through these procedures unscathed. Thus, the real flight of Dream Chaser is extremely near. Long before the original shuttles were retired in 2004, the concept of Dream Chaser was conceived. Years passed before Sierra Space even made an appearance. But when they did, they acted fast to upgrade the Dream Chaser design and replace the original shuttles. Sierra Space and its partners started working on building what we see today in 2012. To prepare it for flight, they are writing test articles and carrying out independent tests with multiple modules that attach to the back of the craft and can inflate to form a large habitation area or store more cargo. The team has created an incredibly durable spaceplane with a cargo and crewed variant thermal tiles that are lighter, stronger, and more advanced than the ones on the shuttles. This cargo module, called the Shooting Star, features deployable solar panels to generate additional power as needed for cargo flights. It can carry both pressurized and non-pressurized cargoes. Dream Chaser and its modules are designed to be housed inside a typical 5M fairing, which is a size that can be handled by the majority of conventional rockets or at the very least by the heavy lift rockets that can launch Dream Chaser into orbit. For redundancy, NASA intended the system to function on any heavy lift rocket. That explains why everything folds up as neatly as it does. Dream Chaser was supposed to make its maiden flight on ULA's new Vulcan rocket. However, there were some obstacles due to delays in finishing both projects. Although most of us are aware of Vulcan's problems and the Blue Origin before engine saga, Dream Chaser was also a little difficult to handle. These thermal tiles are so advanced that, to be honest, they could cover an entire show on them alone. But even the installation took years. This delay was a significant contributor to the initial vehicle's construction time, which was named tenacity. It was probably caused as much by the team's unfamiliarity with the new tiles as by their complexity. Fortunately, this slowdown allowed for the nearly perfect synchronization of Vulcan and Dream Chaser's maiden launches, with Vulcan's scheduled launch on January 8th, following a postponement due to ground system issues. This initial launch is scheduled to occur in January or March of 2024 and will involve a cargo run. Dream Chaser and its Meteor module will be mounted on the Vulcan rocket's new center upper stage and placed into an orbit that intersects the International Space Station. After a very careful 6-hour approach, the cargo was exchanged, the vehicles separated and returned to the planet, and the Dream Chaser glided back to Kennedy Space Center, landing on the runway, and the Shooting Star and its payload burned out atmosphere trash. Currently, Shooting Stars are made in this way as consumable items, and the company is working on an inflatable heat shield that could one day allow them to safely parachute back to Earth and be reused. Sierra plans to complete at least the first 30 launches of its 2 Dream Chasers with this disposable version and is also busy building production lines to accommodate it. SpaceX is busy preparing its Boca Chica, Texas launch site for the next test flight of its super heavy Starship rocket. But new information provided by NASA itself reveals the purpose of this third flight test. It became clear what exactly it was. SpaceX conducts the first propellant transfer test. Fuel transfer is one of the most important functions of a spacecraft platform. An orbit refueling from one spacecraft to another greatly expands the scope of the mission and, above all, allows NASA to temporarily suspend the use of a human landing system by one of its crew members on the lunar surface. This is one of the requirements for permitting use on the planned launch date toward the Artemis 3 Starship mission in 2025. There is little time left for SpaceX to complete all the necessary tests before it is certified. SpaceX is known for working quickly, but conducting a test like this requires many factors to come together. When NASA's Deputy Administrator for the Moon and Mars program spoke at the National Academies on December 4, attendees noted that one of her slides mentioned that the spacecraft's next flight would be a fuel transfer demonstration. I was shocked when I saw it. As I said, SpaceX is fast, but they're not magicians. The FAA is currently investigating the November 2 explosion, and a third test flight could be weeks away. How can he accomplish something as complex as fuel transfer using just one launch pad for his next test flight? NASA spokesperson Jimmy Russell shed some light on this mystery. He will guess. This is not a conversation with news, his outlet RS Technical. Jimmy revealed that NASA and SpaceX are considering options for demonstrations to take place during integrated flight tests of spacecraft and super heavy rockets. However, no final decision has been made at this time. According to Jimmy, this first test was an internal tank-to-tank swap using hardware already on board the Starship, and after stage separation, he was able to transfer approximately 10 tons between his two tanks inside the Starship and transfer liquid oxygen. This plan has been in place since 2020 and is a somewhat reasonable first attempt. A second ship is not needed and will test many of the internal systems of valves and actuators needed to safely move cryogenic fuel in zero gravity. So that may not happen yet, in which case Jimmy makes it clear that two spacecraft docking in orbit won't be the test we think it is. This will be the final result of the final test of the series, proving that the Starship can transport the maximum amount of fuel. SpaceX prefers to test her one at a time while completing test flights, and Jimmy revealed that her Starship could be safely outfitted in time for the first fuel delivery test. The third test flight was by no means a large-scale test. It's pretty wild to hear that this could be the next launch, even though it's in a more reasonable range. But even if SpaceX tries to fit in with Artemis 3's 2025 launch window, it's still at 2024 has many milestones to achieve. Perhaps the next test will allow full flight and fuel transfer. Avio, the maker of the European Space Agency's Vega rockets, is in big trouble. They lost 2 fuel tanks on December 4th. Sources at European Spaceflight, a spaceflight news organization, said in early October that Avio discovered that 2 of the 4 fuel tanks for the 4th stage Las Vegas AVAMS were missing. It was reported that I threatened to cancel the last flight of the last operational ES rocket. It took Avio a while to figure out what had happened, but it appeared to be a tracking mix-up. For some reason, his 2 tanks in question were not registered in the company's inventory system, which tracks all launch assets, according to people close to the project. This made it difficult to find, let alone find out what had happened, but the 2 tanks were eventually found destroyed in a nearby scrapyard. An unmarked tank was mistaken for trash and taken away during renovations at an AV manufacturing facility. The bigger problem is that, as mentioned above, Vega will be discontinued after this launch, so there's no other hardware here waiting to be replaced. This last mission was intended to launch the European Earth observation satellite Sentinel-2C into orbit, a mission that ESA deems urgent enough to launch another satellite. A biomass forest measurement vehicle is also planned, and I am a little excited if a solution is found here. One such solution is to refurbish the old fuel tanks used for ABAM's 2012 certification tests. However, it is no exaggeration to say that it will take a lot of effort to get these tanks flying again. Another option, though risky, is that Avio could take tanks from Las Vegas ABAM plus stage 4 and modify them to power its big brother. Again, there's no way to know if it will work, and it would take months just to try. The safest option is to wait until Vega SEU is ready to fly, which will likely be late 2024 at the earliest. The rocket is undergoing some repairs after its second flight last December failed due to a defective engine nozzle. So unfortunately, there doesn't seem to be a good solution here. It's frustrating to have to wait an entire year to get an important scientific research platform off the ground. That's all for today. Hope you liked the video. Don't forget to give our video a thumbs up. This keeps us motivated to make such videos.